So, next thing we're going to mention is using Pythagoras in the real world. So if we get a question that's talking about somebody trying to find something in the real angle or that sort of thing, the big thing that I'm going to mention here is that in the real world, there's a couple of assumptions we make. So firstly, if we have any rectangle, so normally this is something like a bedroom or, well, any kind of room or a football field or something like that. Firstly, we always assume that in the real world, all the corners are actually perfect right angles. Even though realistically an exact right angle, we always assume that this means that if I draw a line from one corner to the opposite corner, then I have essentially made a right angle triangle. Okay, so if I follow this, all right, I've made my right angle triangle because you can clearly see that that there is a right angle. So quite often when it comes to bedrooms and things like that, from corner to corner, we can suddenly make a right angle. And of course, using that right angle, we can then find the distance from corner to corner. The other thing that I'm going to note here is that if I go back a little bit, if, for example, I have to find something that isn't, I might do this in green, if I have to find something that isn't actually in the corner, let's say I have to find something there, all right, and I have to find the distance, for example, that it will be, not from there, that it will be from this corner of the room to there, okay, then I can still use a right angle triangle. Even though there isn't one drawn, I can pretend that there's a line here, which will of course be the exact same length as this wall, all right, and it would be a right angle still. Let me make my little right angle symbol. All right, so that there will still be a right angle. So long as the line that I draw is parallel to the wall, that would still make a right angle. The other thing that I'm going to note for you guys is that a lot of questions will involve something like this. Here we have our ground, and then we have something like a tree. Here's my perfectly drawn tree. Good tree. So what we're going to do with this is we assume that the tree is actually at a right angle. This also occurs sometimes when we talk about buildings. All right? If we have a building that's built, we assume that it's not some, really awesome architectural building with points coming out or anything like that. We assume that it's actually perpendicular to the ground. So what we can assume with these ones is that in here, all right, that bit there, we can assume that it's a right angle. Or if we look at the tree, firstly, there's a couple of things that we do. We assume that it's essentially just a straight line up and down. We don't worry about the width of the tree at all right? But yet again, we assume that in here, let me point to it, in there, that is a right angle, okay? So once I've done this, let's worry about the tree. So I will rub out the building, okay? Get rid of the building. Lovely. So for the tree, we can now assume that if we need to find the distance, some generic distance from the tree, let's mark it over here with an arrow. All right, if I need to find the distance from there to the top of the tree, I essentially have a right angle triangle, 1, 2, 3. Because I assume that the tree is